Okay. Oh. Okay, let's start. I know some misstyled this video. I'll fix that after just recording. So max contiguous subarray sum. So you're given an array, and you're asked to find the sum of the, or maximum sum value of the contiguous subarrays. Naive approach. Be first to, you can go through all the subarrays, but first I want to go through what contiguous is. Contiguous means they share a common border or touching or are next or together in sequence. I'll show you what I mean right here. Let's switch over to my whiteboard. Oh, I'm at my whiteboard. Okay, and I also forgot to show my face. But okay, yeah, okay. Bring this up. This is transition. I got a little problem with Logic Cam. Maybe it'll work, maybe it won't. Who knows? There we go. Let's fix it. Okay, there we go. So contiguous, they have to be right next to each other, obviously. And look for a max, contiguous, subarray sum. These are the key values you want to consider when you're working through this. These are in the problem statement. So, of course, we're going to go through here. So contiguous, what I mean is, for example, we have 1. 1 could be contiguous of itself. 1 and 2 are contiguous, they're both touching next to each other. 1, 2, 3 are contiguous, they're both next to each other. And also 3, 5, and 1 are contiguous, they're all connected next to each other, touching. However, something like 1 and 3 are not contiguous. As you can see, there's a gap between index 0 and index 2. They're not touching, so not contiguous. Same as 3 and or index 2 and index 4. There's a gap. Index 3 is in between. Same case with index 1 and index 2. Not contiguous. Okay, and since we're working with array, one thing you can use is, like, we use dynamic programming. I mentioned, as you can probably figure out as we go along, dynamic programming is not necessary for this problem, but it's a good problem to demonstrate how you use it. Basically, keep track of some values as you go along. Yeah. Okay, and since we're looking for max, another good hint, we're returning to max sum. Put that in. Okay, sorry about I'll clean this up real minute, because fun fact, I was doing this, did not realize I was not recording, so hey, another practice round for live thing. So yeah, let me clean these out. So I also realized that other stream went way too long, so good thing about that, give it another try, because this is going to be the final one take. Okay, make sure we are still streaming. Good. Okay, so yeah, let me clean this up. Let's go to the whiteboard, and also since this white tablet I'm working on, screen, Microsoft Surface, is right here. Face will be looking downward, so I'm going to get rid of this camera. Let me fix it. Just bring this. No, I don't want to do that. OBS Studio can be fun. Okay, let me just clean this rest up as well. And also another thing I forgot to mention, keep track of max sum. So we'll be updating this second part of the loop, because this will be our return, what we want to return to maximum sum. Okay, let's get rid of some of that. Okay, and one thing, so like I said, we're going to be using dynamic programming. We're going to have to initialize dynamic programming list. And to do that, to have an initial value, because we're going to compare in our choices. That's what I need to go back to. Almost forgot. Trying to rush through this second screen. Retake. Show my face again. Let's go to that. How we're going to solve this problem. Again, 3 keys to solve problems like this, and many algorithm data structure problems as well. First, consider your choices, your constraints, then your goals. Your goal. I'll say our goal, find the largest sum value in our array, so I'll go to that. We can return the sum with the maximum contiguous segment in the array. That would be, constraints. Also, we have a beginning. The array has a beginning. Also has an end. And the sum must be contiguous segment of the array. Let's see if I can shrink my face a bit. Maybe I can. Okay, that's better. So I'm just cutting off on the Y. Small thing there. Much better timing too. Still not that great, but 10 minutes. Okay. So as I mentioned, constraints, now our choices. We have 2 choices with this. We have to we can either take the index of the set our current dynamic programming index value to the value of the current array index, or we can set the current dynamic programming index value to the sum of the previous dynamic programming index value plus the current array's index value. That was my grammar in that sense. Not the great, but I'll fix that in annotation. Okay, so let's go back. I'm going to go that far back. Well, let's continue on. Let's go back to my board. Start our first example. I also meant to get rid of these too. Since the first value of this array, we'll have to initialize our dynamic programming index of 0 to array of 0. Since we really have no choice, we can't take the dp I minus 1 plus array I. That gives the index out of bounds because we're going through dp negative 1. So yeah. And of course, so our only option really is to initialize it as that. So yeah, let's bring it down. Okay, so that'll be 1. Let's go. This time I'm going to do this a little bit faster than I did before, but still try to cover what I mean. So array value at current index of array I. We're at index 1 now as we go through this loop. As you can see, start at 1. Go to the length of the array and increment by 1 as we go. Of course, this is how we do it in C. This is how you do the same kind of loop in Python. Starting index 1, less than array length of array, and increment by 1. Okay. So yeah, we are at index of 1 of array is 2, and dp I minus 1, so that was initialized to 1, so that'll be 1 plus array value of 2. 1 plus 2 equals 3. What's greater, 2 or 3? We want to take 3. So we append 3 to the list. Now, we have to consider this. Maxsum, looking for the maxsum to return, so let me fix this up. Come on. Oh, something. is a greater value of dpi or maximum. If so, in this case, dpi, as we mentioned, set it to 3. Maximum, and before I forget, maximum also has to be initialized to the first value of the array as well. Okay. So that will be previous, which was 1. What's greater, 3 or 1? This time 3 is greater, so maximum was originally 1, now it's the 3. Next up, incremental loop. Index. Clean this up. Try to clean this up at least. So now that's 3. Now we're increment the index. We were at 2, finish 2, we are now at 3. 3. So of course, work through this. Array of I at index 2 is 3. dpi minus 1 is 3. Array I is 3. 3 plus 3, 6. What's greater? 6. And let's say dpi is 6. Let's convert maximum to 3. What's greater? 6. Maximum is now 6. Continuing on with this down. I'll probably skip the second example. Well, yeah, well. No, actually, never mind. I will go through it. It's much quicker, though. I'll still go through all 3 of these examples. I'll clean this up. Okay, so now that's cleaned up. Let's continue on. Increment our index and get 5. We're index 3. Value of array at index 3 is -5. -5. And now compared to a 6 plus 5 plus -5 is 1. Yeah, sure. So -5, so 1. What's greater here? -5 or 1? Obviously 1. Okay, dpi is 1. What's greater, 1 or 6? Obviously 6 is still greater, so 6 still holds the lead. That's the 1. Okay. Let me get rid of that so we can actually see. Sorry, I was keeping this covered up. My bad. My face was in the way. I'm sure you don't. Come on. Sorry. There we go. Okay. I just came to the fact that nothing's perfect. I'll never get a perfect recording. So we're going to do the best we can with this. Okay. So now we are at 1. Okay, so 1 up there. Max, which I know was cutting out because of my face. Maximum will be the max of the current dp value, and max up. So now increment 30 by again 1. So array of index 4 is 1, 1, 1, and that will be taking previous dp value, which was 1. Okay, sorry. And just start. 1 plus brain fart. Yeah, dp previous dp is 1 plus 1, which is array I. That equals 2. 2. What's greater? 2, obviously. So now we take 2 down here. We append 2 to the list first of all. Now we can compare 2 to our current maximum sum of 6. What's greater? 6. So 6 maintains lead, and since we finished our going through the list, we also return our maximum, which will be 6. So this one equals 6. Okay. I really can't skip to the next one because I noticed my fat face. My face was in the way as I was going through this part here, which is again critical because we need to keep track of our max sum which does change as we go along. So again, let's start. Bring down our initial 5, so negative 5. Now, so now max sum will be initialized to array 0, so that will be initialized to negative 5. Bring this up to. Okay, so now, and sorry with all the writing I've been doing on this, it's getting really messy. Array of x1 is 1. So we either take 1 or previous sum back. So that'll be negative 5 plus 1. That'll be negative 4. So negative 5 plus 1 equals negative 4. What's greater? Obviously, 1 is greater. So we append 1. Continue on. What's greater? So dpi is now 1. Maximum is still negative 5. What's greater, 1 or negative 5? Ooh. 1's greater than negative 5, so that maximum is now 1. Bring this back up here. Sorry, I don't know why I erased it. Yeah, because I'm trying to make this visible. Okay. Continuing on. Our 22 minutes. Basically continue this approach. Clean this up first. Now we are at 2. Increment our index. So we're at right here. That's our current index. So, no. Yeah, that is our current index. Sorry. Let me fix this. Negative 5, 1. Yes, writing on this thing is really hard. So now we can either take 2, which is 5 array I. Let's pretend that's a 2. I don't know how ugly it looks. And our previous dp was 1, so 1 plus 2 equals 3. What's greater? 2 or 3? Obviously 3, so we append 3. Now dpi be 3. Maximum is 1. Maximum, erase that. So what's greater, 1 or 3? 3. So now maximum gets incremented to 3. Okay. So make sum of 3 now. Let's clean this up. And let's increment our values again. So DPI is max of -513. No, sorry. No. Current index has been incremented to index 4. Or sorry, index 3. I'm there. It's late. You can tell by the time on this clock. So yeah, we're at 3. So we can either take -3 or DPI minus 1, which is 3 plus -3. That equals 0. What's greater? 0. So we pin 0. Now DPI is 0. Maximum is 3. What's greater? 0, 3. 3. So maximum stays the same, it's 3. Final the index value. Index 4. Okay, so we take -4. And or DP of I minus 1 is 0 plus -4 is so much right over right. -4. -4, they're both the same, so we can take it either. So spent -4. Now from here we have DP I1. Let's see. -4, 3. What's greater? 3. So maximum remains the same at 3. This is the end of the list. We can return maximum, which would be 3. Final example. As you could tell, from the bottom, I already had this coded out. I intended to write this code as we went along, but and I'll just explain it to you as I. Yeah. Didn't realize I was not recording. Happy accidents. This will also save a bit of time too. So okay. So first, again, bring down our initial array of 0 is our DP of 0. So that would be -5. This is -4. I can get this clean. That's a 2. -2. I know it looks like chicken scratch. Sorry about that. So yeah, since we finished that, we're starting a new problem. I'm going to clear this up. And I didn't mean to erase that. Okay. So yeah, clean this up too. Okay, let's begin. Index 1. Starting index. I'll say array I of index 1 is -4. Let's compare it to our previous DP. I minus 1. DP I minus 1 is of course -5. So we have -5 plus -4, and that's equal to -9. What's greater? -4 or -9? Obviously, -4. I'm so sorry about this handwriting. Increment our index again. Well, before we increment our index, okay. To work out the maximum. Of course, that was initialized to the from previous example. Of course, sorry I didn't do that down here. Keep track of where I am. Maximum is again initialized to array of 0. Because it's the only thing that has to be initialized something. And if other reason you think of, what if we only have array of size 1? Maximum will be the sum of the single element, because the contiguous element can be by itself. Okay. Now where was I? 49. So it was -5 originally. Then it's not. It was -4. -5. Obviously, -4 is greater than -5, so this gets upgraded to -4. But this says -4 now. Maximum is -4. I'll set this comparison later on. Now let's continue on. As you can see with this problem, very simple straight pattern. As I mentioned, max contiguous sum value can be by itself. Keep note of that. So here now we increment our index to 3 to index 2, which is -3. So -3. Comparing that to dpi minus 1, which is -4, plus array of I, that is, of course, I'm blanking it. Tired, sorry. -3, -7. What's greater? -3 or -7? I'll see -3 is greater. So now we go append that. -3 greater than -4? Yes, it is. So that we update max sum to -3. Now we can increment our index again. Almost done. We're at index of 3, which is -2. So -2. Let's compare dpi minus 1. dpi minus 1 was -3. Plus -2 equals -5. What's greater, -2 or -5? Obviously, -2 is going to be greater, so we're going to append -2. Now we can compare that was supposed to be -3. I didn't mean that. So now -2. -2, what's greater for max sum? -2 or -3? Obviously -2, so the maximum gets incremented again to -2. Updated to -2. Sorry about that. And I just erased something I didn't want again. So let's set that -2, clean this up before we start incrementing our values. Okay, last one. That's the index. Index of 4. Okay, array I at index 4 is -1. dpi minus 1 is -2. So -2 plus -1 equals -3. -3. What's greater? Obviously -1 is, so we append -1 to our dp array. whatever you want to go there. So now, -1 is our DP value. What's greater, -1 or -2? I'll say -1, so -2. I guess I'll increment again. And since we're at the end of our array, maximum in this case would be -1. Okay, now go through the code. And one thing I've almost forgot to mention is the reason why we're using a dynamic program. Again, like I said, we're giving an array. And look for a subarray. And like I said before, dynamic program is not necessary to solve this, but like I said, it shows it how you can use it, how it's used. As you can see, DPI -1. So we're recalculating. We just wrote for the DP table. Basic memoization. DP list, sorry. Okay. So now the code. Lastly, we want to start with a low-hanging fruit. And this is something you want to always ask your interviewer, what they want you to return if the input is going to be none, empty, invalid. In this case, I'm going to be returning -infinity. But like I said, I make a point I always ask. Always make sure you do this check too. Good practice. And also when you're doing code, make it as clean and readable as possible. In Python, you don't have to specify the input type parameter or the return type parameters, but you can. Or you could also put them in a mini doc string like I type int. Right? R type, return. That'd be just an int. But yeah, either method of these will work. Just to make sure it's clear what you're taking in. Just take case an array of integer. And we fix that type error there. That looks horrible. Okay, that's better. Okay. So now, yeah, let's continue. Of course, we're setting our max sum to the initial value of the array, which is array 0. And of course, setting our DP array to array 0 as well, or in this case, max sum. This is DP is 0 is now max sum. So basically, I'm just going to make sure these are equivalent to basically what's in DP is 0. But of course, we need to initialize DP array, so that figures it as well. Okay. For I, now we need to go through the loop, starting at from 1 to the length of the array, incrementing by 1. So from I in range 1, length of array 1, okay. DP, we append the max of array I, and of course current sum or DP I-1 plus array I. One thing I would like to point out, think of dpi minus 1 as max so far. If I could write. Yep. So that's our max so far. Now, of course, then we need to keep track of the max sum, which is the value and our goal is to return, which that would be the max of course, dpi, or max sum overall. As I showed up there, we basically incremented max sum as we went along. And finally, we just returned max sum. I'm sorry, oh, I just skipped around. Yeah. But obviously this does leave room. This method is linear time and time, because we have to go through the entire array. But it also is in space, since we're using a dynamic program memorization table to keep track of max so far. However, like I said, dynamic program is not necessary to solve this problem. You could just keep track of max so far with its own integer value. I'll show you. This is basically part of the bud method where I bring this up, bring my face back so it gets a view again. Okay, let's go bring this up. Oh, how we can improve these problems. You have look common recommended approach from in the correct decoding interview by Gail McDowell, if I pronounced the name right. First, look for bottlenecks. Not really many you see here. Then you can also look for unnecessary work, and then finally duplicate work. Here we have unnecessary, well, kind of unnecessary work with a DP array. Could be optimized a bit further, cutting down on space complexity by just getting rid of that and using max so far. I'll show you what I mean. So we go down to our optimized code. If I can write it. Okay. So yeah, we'll keep track of current sum. Basic. Same exact as the previous method, but of course current sum is used instead of DP. Keep track of our max so far. Same, we have to go through the entire loop from 1 to length of the array, incrementing by 1. So this time, like I said, instead of keeping track of using dynamic programming, we're just going to use current single integer value, and that is incremented whenever. Same logic for the DP. Yep. Whatever is greater, either array I or current sum, plus. Made a mistake. Knew something was wrong here. Okay, yeah. So instead of dpi minus 1, we'll just use current sum I plus array I, whatever is max. Upgrade that. Then max sum. Basically taking the max sum is whatever is greater from current sum. Max sum. And so if current sum ends up being greater than max sum, for example, current sum is negative, or is 2, maximum is -5. Obviously 2 would overtake -5. So then maximum, even though it was -5, is now 2. And now finally, we just return maximum. As you can tell, these methods are very similar. But instead of using the array to keep track of the maximum far, just use an integer value, current sum. That is, as I said, initialized. I'm so tired. Yeah. Same logic. Maxsum is initialized to array 0, and current sum is initialized to maxsum. So basically, current sum can also be initialized to array 0. Same thing, same logic here. Okay. Now this is still a little bit rough. Best run so far though. It's under 50 minutes. Get better. But yeah. But overall, the time for the optimized solution, of course, would be still linear. So I have to go through the entire list of the array. But also, the space be improved from being linear and the first one, since we're only keeping track of an integer for the max of our current sum, it's now constant. So here we have time equals O to the n, space equals O to the n, optimized, time equals O to the n as well, but space equals big O to the 1, or constant. We're not looking another array to keep track of anything. So yeah, again, these will get better as I go along. Just takes practice. That's why I'm doing these videos. Yeah. Okay, good luck. Take care.